mumbling. Okay, so we've talked about the standard measuring system in the first hour. So for the second hour, we're going to talk about metric. In our metric measuring system, each type of measurement only has one unit. Length is measured in meters. Now a meter is actually slightly larger than our yard. Our yard is 36 inches. A meter is like 39.4, 39.38 inches, which has always been frustrating. I remember when I was younger, I always thought, boy, it would have made life so much easier if they had just made a meter equal a yard. Well, we mentioned that standard units were not necessarily standard. The metric meter was designed to be equivalent to the Swiss yard. It was designed in Switzerland, so it is equal to a yard, just not the one we use, unfortunately. Let's look at capacity. Metric capacity is measured in a liter. And liter, the size of a liter is defined to be quite a handy conversion. We'll go over that a little bit. And then mass, notice I didn't say weight, I said mass, is measured in grams. I'm going to put weight off to the side over here because we're not going to use it much. Weight is actually measured in newtons. Most people haven't heard of that one. Kind of like the slug in the standard system. The newtons are in the metric system. Most people don't use them. So these are the three units we're going to use for pretty much everything. Now, if we want to measure something smaller or larger than each of those units, they use metric prefixes. So I'm going to do some abbreviations here. We have a meter is abbreviated M. Liter is abbreviated L. Gram is abbreviated G. Now, when I first learned the metric system, I was told that a liter was always abbreviated with a capital L, not a small l. The reason for that was older typewriters and type fonts, a small L and a 1 were indistinguishable. In fact, some of your old mechanical typewriters, and I realize most of you have probably never even had to use a regular typewriter, you've word processed everything. But some of the older mechanical typewriters actually didn't even have a 1 key, you just used the small L. But with modern fonts, a small L and a 1 are usually distinguishable, so it is okay to use a small L to abbreviate liters. You just will probably always see me use a capital L. The reason was, something like that. Is that 51 or is that 5 liters? Well, if I do this, it's obvious that it's 5 liters. So if I want to measure something smaller, they use the metric prefix deci. Deci stood for 1/10. It's abbreviated with a D. So you had dm is a tenth of a meter. dl is a tenth of a liter. And dg is a tenth of a gram. Smaller than deci was the prefix centi. Centi was 1/100th, abbreviated with a C. So cm was a centimeter, cl was a centiliter, and cg is a centigram. More popular was milli, which means 1/1000th. Millimeter, mm, milliliter, ml, milligram was 1,000th of a gram. Now you can see here they went every 10, 10, 100, 1,000. To go smaller than that, they stopped going every 10. They didn't do 10,000th and 100,000th. They skipped straight to a millionth. And a millionth was micro. So the abbreviation for micro was the Greek letter mu. Since M was already used for milli, looks like kind of a U with a long tail or a P with an open top. Mu-M was a micrometer. Mu-L was a microliter. And mu-G was a microgram. Now, where micrograms and microliters are used the most is in the field of medicine. In the medical fields were one of the first fields to have to use a lot of computers and log everything into computers. Well, on the computer, does anybody know where the mu key is? Yeah, there isn't one, is there? So in the field of medicine, they started using the abbreviation mcg for microgram and mcl for microliter. So you may see that alternative abbreviation. Now there are smaller units. We could go to nano, which is a billionth. That's really tiny. You might hear a lot on the news about nanotechnology or nanoscience. That's just science of things that are really small. A nanometer is about the size of one atom. So nanotechnology is dealing with things on the size of an atom. Going larger. Bigger than a meter. We might have deca, which stood for 10. Now D was used for deci, dm was decimeter. So for deca they used DA. So DAM was a decameter, 10 meters. DAL was a decaliter, or 10 liters. DAG was a decagram, or 10 grams. Next came hecto, which is 100. HM is a hectometer, 100 meters. HL was 100 liters. HG was 100 grams. And then the one you've probably heard the most of, kilo, is 1,000, because we've probably heard a lot about kilometers. KM. Kiloliters, not so much. Kilograms, you hear a lot of. We tend, for the most part, when we're measuring metric mass, use kilograms. In fact, when we measure metric weight, we tend to call it kilograms, even though it's not technically a weight, it's a mass. We measure the weight of people, usually with a modified kilogram. It's become acceptable to say kilogram measures weight, even though it is just mass. And then just like on the other side, we went 10, 100,000. We don't go to 10,000 or 100,000. We skip up straight to 1 million. That is mega. It's abbreviated with a capital M. So capital M, little m is a megameter, which is 1,000,000 meters. Capital ML is a megaliter. Capital MG is a megagram. Now a megagram is 1,000,000 grams, or about 1,000 kilograms. Well, exactly 1,000 kilograms. And that has actually been defined because it is close to, a little bit bigger than a standard ton. That is defined to be a metric ton. At this point, when they're dealing with international trade, and they start talking about a ton of grain or a ton of coal or whatever, they are generally now talking in metric tons. Now for these units, the main unit caught on in all of them, meters, liters, and grams. But they thought that the deci and centi and deca and hecto would be handy, but they didn't turn out to be. We tend to not use deca and hecto hardly at all. We jump straight up to kilo, kilometers, kiloliters, kilograms. In fact, a kiloliter is even quite large. We don't use it that often. But kilograms are pretty popular. Going the other way, milli is the one that gets used. We use a lot of milliliters and milligrams. We don't hardly ever hear centigrams or decigrams or centiliters. In the United States, in Europe, not so much. In Europe, they use millimeters. But in the United States, when the metric system is used, centimeters get used quite a bit, just because that is the metric unit that is closest to the inch, and that's what we're used to. It's actually 2.54 centimeters in an inch, which isn't even that close, but it's the closest. In the medical field, you do hear of a deciliter using a lot. Your blood tests, if they test your cholesterol, and they say your cholesterol is at a 127, that's 127 milligrams of cholesterol per deciliter of blood. That's per a tenth of a liter of blood. To convert in the metric system is actually quite simple. Let's say I have, oops, that's what I want. 4.2 meters, and I want to convert it into centimeters. Well, I look at my chart. On the chart, here's meters right here. Centimeters is over here. So to get from meters to centimeters, I'm moving 2 spots to the right. Well, each spot on my chart is either multiplying or dividing by 10. Is a centimeter smaller or larger than a meter? It's smaller, so the number has to get bigger. When you multiply or divide by 10, the decimal point just moves 1 spot, doesn't it? So we move 2 spots on the chart. The decimal point moves 2 spots. So it's 420 centimeters. We have 370 milligrams going into grams. Well, milligrams is right here. Grams is here. To get from milligrams to grams, we're going to move 1, 2, 3 spots to the left. So a decimal point goes 1, 2, 3 spots to the left. 0.37 grams. So the conversions in the metric system are extremely simple. There is none of this 3, 12, 5,280, or 16, and none of that crap. As we mentioned before, when they developed the metric system, they had the benefit of being able to observe literally thousands of years of the standard measuring system and seeing what went well, what worked well with it, and what was difficult to work with. And they planned the metric system to go around that. One of the first things that was just like we saw here, everything is 10. There's 10 of everything in the next bigger unit. So it's just moving a decimal point. You know, if I have to go from, let's say I have 0.07 milligrams and I want to take that into micrograms. Well, milli to micro, that's 3 spots on the chart. Or from 1,000 to 1,000,000 would be 3 spots. So I just move my decimal point 3 spots. So everything when you're converting with metric units is just moving a decimal point. The other thing they fixed was this whole clumsy conversion that we have up here of 1 gallon being 230 cubic inches and 1 cubic foot being about 7.48 gallons, and 1 gallon weighs about 8 pounds, and so on. Very clumsy conversions from one unit to the other. In the metric system, 1 milliliter is defined to be 1 centimeter by 1 centimeter by 1 centimeter. In other words, 1 cubic centimeter. So you ever hear 1 cc? That stands for cubic centimeter. So 1 milliliter is 1 cubic centimeter, or 1 centimeter cube. So if we have an object that we know the measurements, the dimensions of, and we're going to talk about calculating volumes and stuff like that later, if we know its volume from its length dimensions, we can turn it into a capacity, into liters and milliliters very quickly using that. And also, 1 gram is defined to be the mass of 1 milliliter of water. So 1 milliliter of water is 1 gram. 1 liter of water, which is 1,000 milliliters, is 1,000 grams or a kilogram. Pretty convenient. Okay. Our next step is to convert between metric and standard units. Now your book has this in there somewhere, has a bunch of different conversions between units. Here, let me find it for you. We are dealing in chapter 10 here. Backing up a little bit to .576. There we go. Yep. Thank you. Page 576 has our conversions between metric and standard. Now, bless you. This is not how I normally do conversions. I'll show you how I normally do it because I like to keep things efficient. And then I'll show you how the book does it, because in my math lab, depending on which conversion factor you use, it'll round differently. And in my math lab, it expects you to use a specific conversion factor. So I'll show you how to determine that. I have always operated just using a single conversion factor for each one, like for length. I know that 1 inch equals 2.54 centimeters. I've memorized that conversion through the years. And that's the only length, metric to standard conversion I've memorized. If I want to convert 10 feet into meters, you might think, well, it'd be nice to have just a direct conversion from feet to meters. And yes, it would. But I always just do this. We know that 10 feet is how many inches? That times 12, right? 10 feet to inches is 120. Then I'm going to convert inches into centimeters. This is where those conversion factors really come into play. And put inches on bottom so they cancel out, centimeters on top. 1 inch, 2.54 centimeters. And let's see, I multiply. The inches cancel. 120 times 2.54 is what? 324? Don't make me think, it's late at night. 304.8. So 304.8 centimeters over 1, so just 304.8 centimeters. But of course, we still need to convert that into meters, don't we? Centimeters for meters on our chart is 2 spots to the left. Decimal goes 2 spots to the left. So 3.048. Now, I don't expect you to have that metric units chart memorized at this point. You'll be able to use your book or your notes. I like the one that I put in the notes. I don't remember how the book does it anymore, but I know theirs was a little bit clumsier to use than mine was. I mean, they just use tables like they have on 576, if I remember right, for their metrics. I guess they do have one on 571 that isn't too bad. So anyway, what if we were going to convert from feet directly into meters using one of these conversion factors on page 576? Well, we would set this up. 10 feet over 1. And of course, we want feet on bottom and meters on top. Well, the book works on the assumption that we'd rather multiply than divide. So the book always wants this down here to be 1. So we have to look for a conversion between feet and meters where the feet is 1. So if I look here, I have 1 meter equals 3.82 feet, or 3.28 feet. Is that going to work? No, because we want the feet to be 1, not 3.28. Here I have 1 foot is 0.305 meters. That's the one I want. So 10 times 0.305 is 30.5 meters over 1, so just 30.5 meters. Now you can see that rounded slightly different than this. My math lab does not account for differences in rounding in this unit. It'll only take that one, 30.5. What if we had tried to use the other one? What if we had 10 feet over 1, getting rid of feet, going to meters? And what if we used 1 meter is 3.28 feet? It'll work. The feet cancel out. We have 10 meters over 3.28. Now we have to divide out. 10 divided by 3.28, 3.049 meters. Slightly different than what we got up here. And my math lab is going to look for that one, and it will not accept that one in most cases. So like I said, when you are dealing with my math lab, use the conversion factor. It's going to put a 1 on the bottom. We'll do some more examples here. Let's say that we have 7 yards. And I want to convert that into meters. So I put 7 yards over 1. Over here, my conversion factor is going to be yards and meters. Yards are on bottom, so that they will cancel out. And I need 1 yard equal to a certain number of meters. I look on page 576 there, I find 1 yard equals 0.914 meters. 7 times 0.914. 6.398. The yards are gone, so it's just meters. Or I might have 1.3 meters, and I want to go into inches. I'll put 1.3 meters over 1. Over here, what's going to go on bottom? Meters, inches on top. And I want the 1 to be with the meters. I want it to be 1 meter. So I look, I've got nothing that goes from meters into inches, do I? So what am I going to do? I've got 1 meter. It's going to have to go to 3.28 feet. And then this is going to have to be 1 foot. It's 12 inches. So the feet cancel, meters cancel. So that's 1.3 times 3.28 times 12. $51.168 inches and 1.3 meters. Now my math lab will also tell you round to the nearest 100th of an inch or 10th of an inch or whatever, so you're going to have to make sure you pay attention to the rounding. I'm going to have you guys try one just so you guys understand the whole where to put the conversion factor. How about 118 inches into centimeters? Try that conversion quick in your notes. So we have 118 inches over 1. Inches and centimeters, we want it to be 1 inch on bottom, so on top it'll be 2.54 is the one they give. Inches cancel, so this is 118 times 2.54, giving us 299.72. Okay, in other units, capacities, the mass to weight. Let's look at capacity next. Just like the length, I only have one conversion memorized. My one capacity conversion I memorized is 1 gallon equals 3.785 liters. Now I believe our book only goes 1 gallon is 3.79 liters. So I'm going to change that to match the book. Come on. There we go. 1 gallon is 2.79 liters. They have other conversions in the book, but that's the one that I've always used for everything. But let's look at any of our conversions. Let's say we want to know you have a 5-gallon gas can and you go to a pump that's measuring out in liters, how many liters is that going to be? Well, 5 gallons goes over 1 times, what's going to go over here in our conversion factor? Well, I always start with what has to go on bottom because it needs to cancel this out. Has to be gallons down here. On top has to be liters. Where does the 1 have to go? Bottom, 1 gallon. So we look, 1 gallon is 3.79 liters. Gallons cancel, 5 times 3.79. $18.95, you got her. So 18.95 liters. Make sense? Let's say you have a 2-liter bottle. I don't know how many quarts that is. Try that in your notes quick. So 2 liters over 1. There's liters on bottom, quarts on top. 1 has to go on bottom. 1 liter equals 1.06 quarts. So this multiplies to make 2.12 quarts. How you doing? Okay. 2.12? It's in the book, page 170 or page 576 is the book. Oh, sorry. On my math lab, sometimes it does give you the conversion right there. You know, there's a little icon you can click to bring up the conversion table. But you do have to be able to pick out the right conversion. So you gotta pick out the one that gives you 1 on the bottom, so that you're just multiplying. It doesn't matter. You can get the right answer by dividing, but my math that rounds a little different if you divide. So my math lab only accepts the answer that's found when you multiply. Now I'm going to qualify this. If you do, I mean, we could have used this problem here could have been done 2 liters over 1 liters quarts, where 1 quart is 0.946 liters, right? Liters cancel out. You got 2 quarts over 0.946, and you have to divide. 2 divided by 0.946. And we get 2.114. Slightly different from our 2.12. It's not wrong, it's just rounded differently. So if in my math lab you do a problem and you end up using a conversion factor like this where you're dividing instead of multiplying, and it tells you you're wrong, don't worry. In the homework especially, don't worry about it. If you're real close like this, you just divide it instead of multiplying. On the quiz, if you do it and it tells you you're wrong, let me know and I will change that grade. Because I'm not going to tell you have to convert it one way, because I don't. I just have one conversion and I use it for everything. Multiply, divide, or however it has to be done. Okay, so then we still have to talk about the weight. And unfortunately, we blur units here. Because what we're doing is we're converting a standard weight to a metric mass. We use the standard pound, and we deal with kilograms. Kilograms are mass, of course pounds are weight, but we just tend to accept it. 1 kilogram is 2.2 pounds. Technically it's like 2.208 pounds, but this textbook rounds off to 2.2. So if we go to convert, let's say that we have a person who is 210 pounds. We don't know how many kilograms they are. But we're going to put 210, what's that? Perfect. 210 over 1. Now over here, this conversion isn't going to work because pounds have to go on bottom, and I don't want, I mean, it wouldn't be wrong to have 1 kilogram over 2.2 pounds, but the textbook wants you to put 1 on bottom. So if we look, 1 pound is how many kilograms? 0.454. We're going the other way. 1 kilogram is 2.2 pounds, but 1 pound is 4.54 kilograms. So 210 times 4.5 or 0.454. Perfect. 95.34 kilograms. I'm starting to like the metric system even more. Sorry. Any questions? All right. The one unit that doesn't convert nearly as nicely. Temperature. For temperature, of course, we have in standard measurement, we have the Fahrenheit scale, degrees Fahrenheit. And no, I'm not going to spell out Fahrenheit. Okay, I will. Fahrenheit, I believe. And of course, degrees Celsius. That one's not so bad to spell. Degrees Celsius is the metric scale. On both scales, we tend to use benchmarks as the temperature where water freezes or thaws, and the temperature where water boils or condenses. In the Fahrenheit scale, what temperature does water freeze at? 32 degrees Fahrenheit. What temperature does water boil at? 212 degrees Fahrenheit. Good. On the Celsius scale, water freezes at 0 degrees Celsius. And water boils at 100 degrees Celsius. First thing you'll notice, of course, there's only 100 degrees in between here. And if we subtract, there's 180 degrees in between here. Of course, probably the first thing you noticed was that there isn't a common 0 point, right? That's why it's more difficult to convert temperatures. For lengths, 0 inches equals 0 centimeters. There's a common 0 point. For mass or weight, 0 pounds equals 0 kilograms. Again, common 0. 0 gallons equals 0 liters. Common 0 point. That's why we're able to use that conversion factor. For temperature, there is no common 0 point, so we cannot use just a simple conversion factor. We have to use a formula. So let's say I have degrees Celsius and I want to convert into degrees Fahrenheit. My Fahrenheit temperature is going to equal, now the ratio between 180 and 100, if I reduce that, is 9 to 5, or 5 to 9, depending on which direction you're going, right? Well, so from degrees Celsius, you're going to take the Celsius temperature times 9/5 and then add 32 to it, because the 0 point shifts by 32 units, 32 degrees. So if the weatherman came on the weather tonight and said, tomorrow there will be a high of 25 degrees Celsius, would you be happy with that? Oh, I would be, but let's figure it out. Put 25 in for C. 9/5 times 25. Well, on your calculator, just write it as 9 divided by 5 times 25. Or you do 9/5 times 25 over 1 if you want to. It comes out to be 45? Yeah? So 9 divided by 5 and then times 25. 45? Okay. Then plus 32 is 77 degrees. Oh, gotcha. So 77 degrees Fahrenheit. I'd be very happy with a 77 degree day tomorrow. Going the other direction, if I have degrees Fahrenheit and I want to go into degrees Celsius, I take my Fahrenheit temperature, and first I have to subtract the 32 extra degrees And then instead of 9/5, I multiply by 5/9 equals 1 degree Celsius. So let's look at another common one, human body temperature. Anybody remember what human body temperature is? 98.6 degrees Fahrenheit. Let's convert that into degrees Celsius. So 98.6 minus 32 goes first. 98.6 minus 32 is 66.6. And then times 5/9. It's 37. So it's 37 degrees Celsius. It's human body temperature. Did you guys get that one to work out? So in your notes, I want you to try this conversion. If the weatherman said that on January 1st it's going to be 40 below or negative 40 degrees Celsius, how bad is that going to be in degrees Fahrenheit? What'd you guys come up with? Negative 40. It's the one temperature that's the same on both scales. How are you guys doing? Well, I think you guys have probably suffered enough for one night. Since we had a test last class, there is no quiz, but there is a new homework due for Tuesday next week. Like I said, I've been out most of the last couple days, so I don't have your tests done, so I will have your tests graded and back for you on Tuesday as well. Computer lab next door will be open, and I'll be here till 5:20 if you want to work on your homework.